All right, I'm going to go ahead and get started right now. Hi, everyone on this chat. My name is Daniel Perlovsky, and I am a program manager for Azure Data Factory. Joining me on this stream is going to be my colleague, Mark Cromer, who is going to be able to answer any questions you all might have. If you have it on the chat, just feel free to type it in and he'll be responding while I'm going to be kind of going about the explanation, training, and demo that I'm going to be doing for you all here today. So what we're going to be talking about today is continuous integration deployment within Azure Data Factory. For those of you, and I'll be referring to this process as CI/CD. For those of you who don't know what CI/CD is, continuous integration is the idea of really testing each change you've made to your data factory or code base. And this is really a concept across a wide variety of development spaces. But it's the practice of testing each change you made as quickly and as early as possible in a very automated fashion. Continuous delivery is taking those changes and having a very streamlined release process. So if you're going from a dev factory to a test factory to a production factory, you could do that in an easily manageable way. And we'll get into that all throughout this next, probably about hour. Now, I just want to lay down a few ground rules as well as I'm kind of going through this. And by the way, I'm not doing anything on the screen right now, so you're probably just seeing a frozen window. I'm not going to be talking about any sort of data factory development specific things in terms of I'm not going to be going in depth on like what a data flow is and how to build a data flow. This is more kind of going to be highlighting, okay, I know how to build different data factory resources. How can I have a managed, maintained development process so my changes are both, governed and tracked, and also there isn't going to be too many manual steps involved in terms of, okay, I made a change, I want to see this in my production factory, what that sort of looks like. So I'm going to right now show you sort of an image that's going to highlight the demo that I'm going to be doing here today. Now, I'm assuming that you, in whatever organization you are a part of, have three different environments: dev, test, or UAT as it's sometimes called, and production. You could have more, you could only have two, but oftentimes we see this sort of pattern where you have three different sort of variations of data factory environments or ETL environments. Now, in these three environments, oftentimes the actual pipelines are the same, but what's really differing almost always is sort of the connection being used. Are you using your more development test data or your actual production ready workloads? And generally, as you're going from dev to test to prod, those workloads get bigger and bigger until you hit the size of workload, touching the data you actually care about gaining insights from. So within this demo, and I'll get into all of this throughout in depth as I'm going through it, as I said, you're going to have three environments. Only one environment, your dev environment, is going to be associated with Git source control. And I'll get into a little bit about sort of the benefits of source control and why you should have it, but source control really is just a way to manage your changes, track your changes, collaborate with others, and makes really the development of features and pipelines a lot easier within Data Factory. And I'll go into a lot of the advantages of doing that versus maybe the default mode that you might be seeing. And then from there, after I sort of show you how to create a pipeline, merge it into a collaboration branch, and eventually get that into your continuously integrated development factory, I'll then show you how to set up an Azure DevOps pipeline so you could automate your releases from dev to test to prod using the release management infrastructure within Azure DevOps. So to go ahead and get started, I'm going to show you what my development factory looks like. I have this data factory. It's called Dapperlov Dev, Dapperlov being my work alias. And within that data factory, I currently do not have a Git repo associated with it. But this is where, as a developer, I would be making my change. This is sort of the factory that you really want anyone, creating pipelines, creating connections to do that. Now, by default, if you do not configure source control, any change you make to a data factory will be done directly against the data factory service. So say I take this pipeline, and obviously it's a very simple pipeline with a wait activity, but I add a web activity and I make that dependent on my wait activity. I can't save this change without directly publishing it to the data factory service. And that's the data factory service is sort of where all of your triggers are running against, what is actually being scheduled. If you make a web API call, for example, against a data factory, that's going to be that sort of published environment. But as you can see here, I have a web activity that, is invalid. I haven't specified anything with it. If you have UX validation, that will fail. And if I try to publish, it will not let me do that. Now, we do that very intentionally within the sort of default live mode, as we like to call it, because we don't want you to publish invalid pipelines to your, to your data factory that's actually running triggers running against different sets of data. If we allowed you to do that, then, you'd run a pipeline and you'd get you'd essentially have an invalid configuration and would always fail. So I'm going to delete this change, but one of the main benefits of associating with the Git repository is sort of that intermittent saving, allowing you to save without publishing, and also the idea of being able to sort of have version control, easy collaboration, and I'll show you sort of what that collaboration looks like right now. And for those, who really like high performance, integrating with the Git repository actually performs a lot faster than working in live mode. So to configure a Git repository is very easy within Data Factory. If you see this drop down right here, you just click it and click Set Up Code Repository. Now, right now within Data Factory, we have native integration with Azure DevOps Git and also GitHub. GitHub Enterprise is included as well, and within our documentation, we have pretty detailed guides on how to sort of connect to all of those three different things. But in this specific demo, I'm going to be talking about Azure DevOps Git. So I actually already have this Git repo right here within my Azure DevOps environment. It's pretty similar to sort of the factory you see right now, but I'll show you how to integrate that factory with this environment. So every change you make to this development factory will change it. So as I said before, we're integrating with DevOps Git, and I'm going to use my personal DevOps account. Now I already have a project created called Dataflow Demos. And because I have this existing repository, I'm going to associate with that and use master as my collaboration branch. Now, by collaboration branch, that means a couple of things within Data Factory. For one, that is the only sort of branch that you could publish directly from. So you could create as many branches as you want, and I'll show you why you would do that and how you would do that. But to actually publish your Data Factory to the Data Factory service, that publish is going to come from the version that's in your master branch. And if you've been working on data factories already and you already have resources that you've worked on, you could easily import those. By associating a Git repository, you will not use your existing work. So, and my branch already contains resources, but these resources will be ignored if I do publish. But this is going to be more or less one-to-one with what I have. So I'm going to click Apply. We'll check that information, save it, and then you will see sort of the actual development environment will not look very different, but the sort of the process will. So as that's loading, it should just take a few more seconds. As this is loading too, I could show you a little bit more about what's in the CI/CD branch, or in this master branch. So within your Git repository, one of the benefits too is you actually get your resources broken up into individual entities. So if I have that pipeline too with the wait activity showing you, you could sort of see what what's been happening there, the changes that have been happening to it too over time. So I made some changes about 30 minutes ago, and you could see sort of the history of it, and you could also track who's making these changes when they made them. So this wait time in seconds I actually changed today. So if that broke something, you could quickly see what the change was. You could see where that happened and who did that. So this is the change I made at this time. Now this should be done by now. Yes, it is. So you can see it's Azure DevOps Git. It shows the branch I'm working on, and otherwise, everything's pretty similar. I'm importing the resources directly from my factory, so nothing really should be changing. Now, as I said earlier, the master branch is the only way you should publish from your data factory, but you don't want to be touching the master branch itself. Now, I recommend that you don't allow anyone to directly edit the master branch in your Git repository, but you do allow publishing from there. All of the changes to the master branch should be coming from a feature branch. Now, how do you create a feature branch, and really what is a feature branch? So a feature branch is a Git concept of forking a repository and then making your changes and then doing something we called a pull request to merge it back into your collaboration or master branch. Now, to create a feature branch, we have that integrated within our UX. You just click this drop down and you click new branch. Now here it will say, okay, we'll give you a default name, which will just be your alias. And I'll say demo new demo feature. This is creating a new branch with this name. And you could see within your Git repository, you could actually see this new branch sort of come up here. Now, the contents are exactly the same right now because all I've done is fork the branch. If you fork a branch, that will create a new sort of repository that has the exact same contents. But the changes I'll make in my data factory will, propagate here. So say I add a new pipeline. Let's call this pipeline 4. And in this pipeline, I add a wait activity called CI/CD wait. And obviously I'm working with very simple examples right now. The reasoning for this is I just sort of want to show you the process of what it looks like. It would be the exact same if this was a complex pipeline, calling multiple different sources, orchestrating different notebooks, calling data flows. It would all be pretty similar. And I want to click save here. So I'm created a pipeline to click save. Going back to my repository, if I just refresh this page, you'll see, great, I have pipeline 4 now. But going back to my master branch, that pipeline doesn't exist. So within my development factory, this is where I'm making my changes. Say I want to debug my pipeline. I must have added a web activity accidentally. So I realize I don't want to do that. That's why we have that validation. And I actually want to add a wait activity called CI/CD wait. Now we could validate this here. Great, it passed our UX validation. You would run a debug pipeline, which is essentially taking what's just in your sort of UX, running that in a local output, and this will not actually integrate with your monitoring experience. So the only pipeline runs that show up in your monitoring experience are ones called by triggers, either via data factory triggers built in, or things called via the trigger now, or like if you're getting your pipeline called via an external scheduler, like a PowerShell commandlet or a REST API. So say I look at my pipeline and I'm like, great, this pipeline, and let's give this pipeline a good name. Demo pipeline. If I'm like, great, I tested my pipeline locally, I know it's working. I'm ready to kind of merge this with my collaboration branch. What is the process for getting that back into that master branch? Now, this is going to sort of loop you into DevOps, but you're going to create a pull request, or also known as a code review. Now, creating a pull request is essentially creating a difference of changes between your feature branch and your master branch. And within that, you have someone else in your organization, generally, oftentimes two people, look at those changes and pretty much sign off and approve that. What those policies are dependent on your organization. You set that within DevOps. So I'm going to click create this, and it will, Data Factory will, automatically create a pull request for you. Now, as you can see, we have 3 different commits here. Now, these 3 different commits are the 3 times I click save within my UX for my demo factory. You can see those changes as you click on them if you want to look at them individually. But you also, once this change is merged into master branch, these will all be squashed into one sort of commit in the master branch. So within master branch, you could always look at different commit histories. You could see what those changes are being done in each different time. Now let's call this pull request update or create pipeline for webinar. And I could say I created a pipeline. And you could, add your reviewers. Oftentimes, let's add Mark. Oftentimes, you will have policies that will automatically add reviewers. And there's a lot of different customization you can do within DevOps itself. But let's create this pull request. And here you could see, oh, cool, we're adding a new pipeline. Now, if this was a different pipeline, or if I edited a pipeline, that will show you an edit. If you deleted something, that will show up as well. It's a pretty comprehensive, pull request infrastructure. Many different large enterprises use this both for data factories and even just their general. If you're building software, it's a very similar process as well. But say here, I was the reviewer and I was reviewing one of Mark's changes. I looked it over, I click approve, this looks great, and we want to complete this pull request. Now, what completing this pull request will do is it'll delete that feature branch, merge those changes into master, and then also create a commit name right here. So this is essentially saying, yes, I'm done with this feature. I want this in my collaboration branch. So going back to my development factory, if I do click anything here, it'll say, oh, your feature branch was deleted, because it was. I deleted that via DevOps. Use your existing, go to your master branch, and now you can see in the master branch we have demo pipeline right here. Now keep in mind, merging into master does not update the publish branch. It does not update what's actually being run in your data factory service. If you have triggers running on this factory, it will not be running this if it just was merged into master. Now, to get that running against your triggers, you're going to do what we call publishing. Now, for merging into master, that's just sort of a peer review. But for publishing, we have a lot stricter guidelines in terms of what we allow into our service. It needs to pass both our UX validation, and then we have some backend validation that's done as well. Now, say I am ready to publish, and when you're working in the development factory, you should be publishing very often, multiple times a day, because you want this to sort of continuously test. In this factory, I'm sure you're going to have triggers that will run at some sort of cadence, and you want those sort of changes to be tested as soon as possible. Now, unfortunately, right now in Data Factory, we have no way for you to automatically publish to your development factory, so that process is manual. That is some feedback we've gotten, and we are working on that. But to click publish, you click publish here. Now, within DevOps itself, you might have noticed we have an ADF publish branch. Now, this ADF publish branch is sort of going to be an identical copy of what's in the Data Factory service as you're publishing. What publishing does is publishing takes what's in your Data Factory, compiles it into what we call an ARM template. Now, an ARM template is what we sort of use for all Azure resources. It's essentially one really large JSON object that contains the different properties of your data factory. Now, you can always see what your ARM template is if you export it right here. You could actually grab the ARM template of what's in front of you if you want to manually import it into your data factory using the Azure portal. Now, we're not going to do this in this webinar. We're going to just click Publish here. Now, Publish will take what's here, generate that ARM template, update the service, barring it passes validation, and then create a replica of that in our ADF Publish branch. So I'll do that. I'll click Publish. It's gathering our changes. It's showing you the change we made. And let's click OK. Now, as this is publishing, I do want to touch on a couple different points. One is talking about link services. Now, for those that are a little less familiar with Data Factory, a link service is sort of how you connect to different data stores and compute resources. Now, in this Data Factory, if you see right here, we have 5 different connections. We have a data lake storage, we have an Azure Key Vault, a Synapse Analytics workspace, and also an Azure SQL database. Now, with link services, there are a wide variety of different authentication types. Say I'm connecting to blob storage. I could connect either via account key, SaaS URI, managed identity, service principal, or I could do account key and configure Azure Key Vault so my credential information will just be blob secret. Because these store connection information, for a large variety of link services, we actually automatically publish those to your data factory service. That's because you cannot store credentials in a Git repository because that's just not secure, that's not compliant. As a result, we highly recommend all of our users either associate their data factory with a Key Vault, and that'll have some CI or some continuous deployment benefits as well, or use managed identity so you don't have any actual credential information. Managed identity just allows you essentially set that managed identity at your data store level, and it will know, oh, this factory has access whatever tables or folders or containers or whatever the source is that you do have. Now, another thing I also want to talk about is merge conflicts. Now, this is just a Git concept overall. Say I'm working on my data factory and I'm editing a pipeline, and someone else makes a pipeline and merges those changes. Now, what I would do is when I try to merge my changes back, I will probably get an error from DevOps saying, oh, this is a merge conflict. You cannot do this. Now, that's a Git concept that happens with any sort of Git collaboration. Unfortunately, native with Data Factory, we do not have a way to easily replicate that. There's a couple things we recommend for our customers to do. One is you could always just go to the master branch, see what that change was, where that conflict is, and just manually add those changes. So say it would let me publish because there was an append variable activity here. You could just do those changes yourself if it's very small. You also could take the code and just copy and paste this as well, and just paste that code in your editor as well. That will also work. Or you could go to Azure DevOps or a third-party Git source and merge those conflicts there via a merging editor. Now, if you're merging it via Git, something to keep in mind is you will have to know the different JSON properties. While we try to make them pretty clear, so for example, if we have, say we have a wait activity here, the JSON properties will be things like wait time and seconds for a wait activity. They're generally pretty clear names, but we don't expect our customers to, know what the JSON properties are. Especially if you're developing via UX, that's really frustrating. So I would recommend you just sort of look at the master branch and make sure those changes are the properties are the same in both. Okay, so now that we've published, to see what's also in the publish branch, you could just click on Data Factory mode here. and I'm going to discard any changes I might have had. And you could just see what's in your data factory. Now, since we just published, it'll be the exact same as was in the master branch. But this is what your triggers are running against, what's actually being called. This is going to be identical to sort of what's been deployed via this ARM template that you have in your ADF publish branch. Now, a couple things about an ARM template as well. By default, ARM templates also generate parameters. Now, this parameters file is going to have you specify your connection information as you're importing the ARM template. Because we don't save that information, say you took this ARM template and want to manually import it into a different data factory or manually update your factory via ARM template, it will ask you to specify these connection strings. Now, one benefit of this, of using Key Vault and using managed identity, is it won't generate these parameters. And oftentimes as factories get very, very large, you might run into the ARM limit for parameters of 256. And you don't need that many. You could oftentimes reduce that. Now, in my master branch, one of the ways you can reduce that is from what we call a custom parameters file, which could also reduce the number of parameters by, maybe associating things that are defaulted as parameters to specific values. Or if certain properties, such as you want to use an existing cluster ID in a Databricks link service, if that isn't parameterized by default in your ARM template and you want that to be, you could also add that here. Now, I'm not going to go over this too much in depth, but we have a good amount of information on sort of what this sort of syntax is and how to add it to your data factory within our documentation. So to kind of recap of where we are right now, we've made a change. We've associated Git repo with our development factory, created a feature branch, merged that change back into our master branch via pull request, and then published into our publish branch or to our data factory service. Now, in your development branch, you're going to be wanting to do this often, but now say you're going from staging /UAT/test to production, you're going to want to do that a lot less frequently. You're not going to want to update your production environment, every day. That's going to be something you're going to want to do maybe once a week or whatever cadence your organization so chooses. And there's a very easy way to sort of automate that process as well. And that's going to be sort of the second half of this, this demo that I'm about to go into. Now, in our publish branch, as I said earlier, we, where is it? Here we go. We have this ARM template with these parameters. Now, one thing I set up was a release pipeline which points. Now, by the way, a release pipeline where I just went is a built-in service within Azure DevOps. I'll show you how to create that. Say you have a lot of different releases. You could just create a new one from releases. And we have very detailed instructions of how to do this in our documentation. And you essentially point a release pipeline at a source. So one thing we would do, say we want to point it at a Azure DevOps repo or a GitHub repository. You would essentially say, what's your project? What's the repository? And what branch you are updating this from. So what this is going to do is this is going to essentially point at whatever in that ADF publish branch. And I've already configured this right here. As you can see, I'm pointing at the ADF publish branch in my repository. And one thing I did actually was, I created automated releases within DevOps. So every time I update that publish branch, I am able to take the state of that publish branch and just publish it within my release pipeline. What a release pipeline is at a very high level is you essentially point it at your source and you have multiple different stages. So this one only has a deployment to my testing factory. And what a setup release pipeline does is it allows you to click on your testing environment and just automatically deploy with the click of a button instead of having to export an ARM template, import it via the Azure portal, all you're going to have to do is click deploy. Now, the factory we're going to be working here is my test factory. As you can see here, it's a lot smaller. I haven't deployed to this in a while. Going back to DevOps, you could see the last time I deployed was 2 weeks ago. This is the current state it's in. Now, something that's really useful about this release pipeline architecture is, so I actually deployed to test a few days ago here, but I realized something was wrong. So I was able to very quickly revert back to this older version, all within a couple clicks of buttons. This makes the maintenance of different versions easier. So say you deploy to UAT and you notice issue with that, you could just go to an older release and just quickly click deploy there and quickly revert. So you can make those fixes, bake those a little bit more in your development environment, and then deploy it back to your UAT environment. Now, within a release pipeline, you point it at your publish branch, and then you deploy it to you essentially have a test task or test stage. Now, in that stage, you're going to have multiple different tasks. As you see here, you have stop triggers. We have create or update a resource group and start triggers. Now, create or update resource group is essentially the equivalent of deploying an Azure ARM template. What this is doing is it's taking what we have in that publish branch associated with this release. And again, it doesn't matter what's in the publish branch currently. Each release is essentially each different change being made to it. You can either manually create one or, as I did, automate them. And what's going to do is it's going to take what's that ARM template, which I'm pointing to right here, and deploy it using this parameters file, which you saw earlier, and these are the parameters we're entering in. Now, these parameters we're entering in are ones that you could either pull from Key Vault, save, or just hard code them, but you only need to specify those once. By specifying these once, every single different time I deploy, I could take these values and then, they're just being reused over and over and over again. It makes it a lot easier. So you don't have to really memorize, say you are, hard coding connection information, you don't have to memorize those credentials. You either could save them in Key Vault or just have them sort of persisted in these pipelines. But again, I highly recommend using Key Vault because in an ideal world, all you would do is you would take this Key Vault and you would just change the Key Vault value as you're going from different environments. And as long as your secrets keep the same name between your link services. So say I have, and as I have right here, say I have the Synapse link service and I'm pointing, at the secret for my password. Now, in my test environment, I have the same link service and the configuration is the exact same and I'm putting at the same password, but the key vaults I have here are different. So as long as I'm just essentially changing the key vault values but maintaining the secret names, it'll be like, okay, this is your test. And if you look at your test key vault, the credential you get is pointing at the correct test SQL server rather than, having to just control different types of credential information. It allows for a nice centralized governed secret store. Now, now that we're ready to deploy properly, we will take this ARM template and it will deploy it using these parameters that we specify here. Something you might notice is we have the stop trigger and start trigger script. Now, if you go to our documentation, this is calling a script that we actually provide for you and regularly update and maintain. What this script does is it pretty much handles any sort of deletion of resources you might have and will stop and start your triggers during your deployment. Now, the reason we do that is if you are deploying to, say, if you're deploying to your test factory and you have triggers running there, you might run into deployment failures if you're essentially updating an active trigger. So this will temporarily stop them, update them, and then immediately start them afterwards. Now, a release deployment is a very quick process. It generally just takes, a couple minutes. You'll probably need the approvals that you need. So it really is not a very long time to have them pause. And by running these scripts before and after, it'll make sure that there's no weird deployment kind of mess ups as you're deploying. So now that we're there, let's actually update this test environment. So let's take this most recent release, which was done, 15 minutes ago, and let's deploy. So if you see here, I only have 2 pipelines and 1 data set. What this is going to do is it's going to take what's in the publish branch here, export that ARM template, import it into this factory, and then specify the parameters that we were using earlier. So click deploy and deploy. Now, if you need approvals, it will do that. It will require those, and that's all within your DevOps environment, allowing you to, really maintain the governance that you do need. So it's queued up and I'll be running. Now this will take a couple minutes. Just other concepts to go over while this is running. Something to really keep in mind is if you're doing this, make sure you're doing incremental deployment loads. Because we're creating and updating a resource group, incremental will only update the resources included in that factory. If you select complete, then that will override all resources and you could end up deleting like a data lake that you don't want to delete. So use incremental. The script arguments here as well are specified explicitly in our documentation as well. So make sure you copy those. And again, you just gotta copy that verbatim and those will apply to all data factories. A couple other things is that we get a lot of questions about, and this is running, you can see it's already almost done. One thing we get a big question about is sort of the being able to incrementally kind of update pipelines. So say you've added 4 pipelines to your development data factory, but you only want to add 3 to your sort of test environment. Now, because we take the entire data factory ARM template JSON file and deploy it to our UAT environment, you have to take everything that's in that publish branch. Now you could change what's in that publish branch via a process we call cherry picking. You could, within that master branch, you could always select, which commits you want to be active at a time. You could do, and these are all Git concepts, you could do what Git calls reverting. So say you have a commit there, you could revert it and add it back immediately after deploy if you don't want to sort of have that pipeline there. But to keep that in mind that everything needs to be separated by a kind of pull request or commit. So every pull request into master is going to include, and I could sort of show you what that looks like real quick. So if we go to master and the history of master, so say we go into pipeline and the history, we could see that pipeline is just, it'll have rename and update as a command, but you could have sort of the change management there and say, I don't want this change to be done. Then you could revert this specific commit and then upload it. So our stage succeeded and we're done with that. Now going to our test environment, if we refresh the resources, you could see this is there. Now we have all of our pipelines, and demo pipeline looks exactly as it was in our dev environment, and it just took 1 click. Now, with that, say you didn't like these changes. If I want to easily revert, all I do is I go back to my releases. I go to an earlier version, and I just click redeploy here. Now by redeploying here, I'll be like, whoa, my changes are wrong, and then I'll go back to an earlier version that I know is valid. So I can fix my changes and then update them there. So that's pretty much the entire demo for CI/CD. To recap, what I did was we had 3 different environments, really 2 in this demo. We created a feature branch in Git, merged it back into master, published it into our publish branch, then using the Azure DevOps release management software, we deployed to the test factory just via Azure DevOps release pipelines. And now what we're doing is we're actually reverting our change to an earlier version, also just through a couple of clicks. So going back to our test environment, let's wait for this to be done. Again, these are pretty quick jobs. Again, they're in the realm of seconds rather than minutes or even hours for some tasks. Let's let this load. And as I'm sort of finishing up, I do want to thank you all for everyone that's been listening. Hopefully this was helpful. If you have any questions, feel free to put them in the chat and we'll be answering them sort of after this call as well. Yeah. I do want to let this finish loading before I sort of end this stream. It's loading. Don't know why this is taking so long. This is normally a bit faster of a process, but yeah, and you could continue this on. This would be the same process if you're going to a production factory as well. So for example, to add a production step, all you do is essentially you would just clone this task and then differ what these template parameters are. So, ideally you just change the key vault and be production key vault. And again, it doesn't matter what's in each of the test and sort of development environments at each time. Each release is sort of one version of that ARM template. So the release determines what's in that version. So say I had a production, I could deploy the test here and that would not change what's in production in this release as well. So it looks like it's just starting the triggers again. So if we refresh this, we could see it's back to that earlier version. So again, thank you all for joining. That sort of kind of covers everything I want to cover within the session. Hopefully it was beneficial. Hopefully this had some clarity. Remember just a couple key things. Don't associate Git repos in test and production. That should only be in dev. And yeah, hopefully you learned something. Thank you all and have a great rest of your guys' day. Thanks.